Okay, so we've been introduced to exponential and logarithmic functions. Now we're going to look at the properties of these, because the next thing we have to do after we learn the properties is how to solve them. So let's look at the properties. The first one is the product rule. What does product mean? Multiplication. Very good. What this one says is the log, if I have two terms where m and n are functions, because they're multiplying, when you multiply things, you make them bigger. So we can split those up by putting a plus sign between them. So here's an example. Log x plus 5, the square root of x plus 3. Because these are both multiplied to each other, I'll take the log of x plus 5 plus the log of radical x plus 3. Example 1. The log base 3 of 9 times 27. Take this as far as you can. So how can I expand that? Of 9 plus log base 3 of 27. Do we know what the log base 3 of 9 is? 2, because it's log base 3 of 9 is equal to some number. So we push it up. So 9 is equal to 3 to the power x. We know 9 is 3 squared. Since the bases are the same, then this has to be 2. Log base 3 of 27. So log base 3 of 27 equals x. So we have 3x equals 27. 27 is made up of what? 9 and 3, and 9 is 3 times 3. So 27 is 3 to the third power. 3 times 3 is 9 times 3 is 27. So x is 3. So this one equals 5. You should also be able to go backwards. If I gave you this equation, log base 2 of p to the third plus log base 2 of q, how would you put those two together? It's right there. We're going backwards. We have this, they're added together. If they're added together, how do I get this? Very good. Since the log base same, just take the two terms and multiply them together because they're added here. The next rule is called the power rule. You cannot have an exponent in your final answer with logarithms. So if you have an exponent for your logarithm, then the exponent goes out in front. Example 3. If I have log base a of 11 to the power -3, how would I simplify that one? B is log base a of the fourth root of 7. How do we rewrite this? Excellent. Excellent. Whatever the root is goes on the bottom. So this becomes log base a of 7 to the power 1/4. So it's 1/4 log base a of 7. ln x to the 6. Perfect. See, the properties of logs aren't that difficult. So that's the power rule. So we talk about the product rule and the power rule. Now comes fractions, the quotient rule. The quotient rule. What this one says is log of m over n. when you divide things, you make them smaller. So that's why this one is going to be the minus. Actually, I'll show you where this came from. I just say because the product makes things bigger, you multiply them. When you divide, you make things smaller, so you subtract them. But here's the reason why this is the rule. If we have a fraction here, we can rewrite that fraction as a product. The m is on top. I could bring the n from the bottom to the top by changing its exponent. Right now it's +1. I change it to a -1. Now it's a product rule. So I have log of m plus log of n to the power -1. The power rule says that negative comes down. And there you have it. That's where it came from. Example 4. Is 8, it's 8 over W here. How do we expand it? Using the quotient rule. Right. That's perfect. Can you go any further? What is 8 made up of? So we can have here, instead of 8, we put 2 to the third power. Now we have a power rule. So this 3 comes out in front. Yeah, this is not a bad answer, what you gave me originally, but in the rules of math is always take it as far as you can. Example 5. Let's go backwards. Log base b of 64 minus log base b of 16. Put it where? Yes. Because it's division, this one goes on the bottom. Ooh, yes, how would you do that? What would 64 be made up of? 8 to the second, okay. And 64 would be Okay. So we could put the 2. They both have a 2, so we can factor it out. What do you do with this? Oh, we could, but since it's minus, yeah, you could, because this would be 2 to the third, this would be 2 squared. We take that out. But let's look at this. We have log base b 8 divided by 4, which is 2. 8 divided by 4 is 2. Since this is a coefficient, it goes up on the top. So this becomes log base b of 2 squared, or log base b of 4. Which is what this one would give. 64 divided by 16 is 4. So there is no, as long as you use the rules, there is no wrong way to do it. But you're right. You could have gone this way here and done it again. 2 to the power 3, 2 to the power 2. Yes, you could have done that. You could have just stopped here and said that this is log base b of 4. But if you didn't see that, then you could have done this thing also. So then there is no wrong way. It's just one way may take longer than the other, but you get the same answer either way you look at it. I'll wait for you. The next thing we're going to look at are some common errors. Common errors. So the first one, log base a of m times n. Why is that an error? You're supposed to add them. It doesn't mean just distribute the log. So that's why this one's wrong. M plus n. Well, this one you're supposed to multiply. What it's saying here is the sum, the log of the sum does not equal the sum of the logs. The log of the sum does not equal the sum of the logs. Here's the most common mistake. You're both supposed to be subtract, right? And another common mistake. Or what's wrong here? Yes, the exponent is supposed to belong to that operation, not to the, because with the whole thing, if I had log of 10 squared, that doesn't mean 2 times log of 10. What it means is log of 10 times log of 10. So those are the 4 common mistakes that occur when we're doing logarithmic equations. All right, let's start practicing using these properties. Applying the properties. Example 6. A. Log base A of x squared, y fifth, z fourth. Express all of these as sums and differences. Let's do it piece by piece. What's the first big thing you see here? It's a quotient. So since it's a quotient, whatever's on top minus whatever's on the bottom. Now we see that's a product in this one. So we have x squared plus log of y to the fifth. Then the last step is the power rule. Each of these exponents come down in front. So we have 2 log a to the x plus 5 log a to the y minus 4 log a to the z. And there's your answer. And there's a shortcut you could have used. That goes when we talked about the rules. If it's on top, it's going to have a plus in front of it. It's going to be positive. If it's on the bottom, it's going to be negative. So we could have gone straight from here to here. If it's on top, since this is a product, you add them, but they both get pluses. This is on the bottom, so it gets minus. We'll come back to B in a second. Expand this one using a shortcut. Remember, anything on top will have a plus in front of it. Anything on the bottom will get a minus. So we get log of BA plus log of BY to the fifth minus log BM3. And since that's on the bottom, minus log BN4. Now get rid of the exponents. Log B of A plus 5 log B of Y minus 3 log B of M minus 4 log B of N. And there's your answer. Difficult level? Not that. I mean, once you see the shortcuts, it makes it a lot easier. Okay, let's look at B now, since I skipped that one. Log base A of the cube root of A squared B over C to the fifth. This one's going to require me to review the powers, the rules of exponents. So my first step is to get rid of that radical. So instead of a radical, what does it become? 1/3. Very good. Now I have to get rid of the parentheses. Actually, I don't have to. How did you do it? No. Because what happened to this power? Okay, yeah. That would be the easiest. Is it goes in front of the whole thing. But then now, since this is over everything here, everything else goes inside there. So now we take log base A of A squared plus log base A of B minus log base A of C to the fifth.
Would that first term be two?
Yes. Because you bring the two down and log base A of A is 1. Very good. So that becomes 1. So we get 1/3. 2 plus log base A of B minus 5 log base A of C. Now I can distribute. 2 divided by 3. 1/3 log base A of B minus 5/3. And those are the answers. But there's another way you could have done it. This is the final answer, yes. But there's another way. Once we converted the radical into an exponent, it's the root is 3, so it goes on the bottom. Or we could have done it this way. This exponent could be distributed to each term inside the parenthesis. And the rule is whenever you have a power to a power, you multiply. So it would have been A 2/3, which is 2 times 1/3. 1 times 1/3 is 1/3. 5 times 1/3 is 5/3. Now we could distribute or expand this one. Log base A of A to the power 2/3. Since B is on top, plus log base A of B to the power 1/3. C is on the bottom, so it's a minus. Log base A of C to the power 5/3. Bring all the powers in front. Two-thirds log base A of A plus 1/3 log base A of B minus 5/3 log base A of C. And that becomes 1. Log base A of A is 1. Which leaves you what's left. Which is the same thing we got earlier. There again, as long as you follow the rules, there is no wrong rule, no wrong step. Now let's go backwards. Here I gave you the short equation, you gave me a longer one. Now let's go from this to give me this. go in reverse. Example 7. Five log base b of x minus log base b of y plus 1/4 log base b of z. What's my first step? Yes. Get rid of all coefficients. Those go back up on top. Very good. We have log base b of x to the 5th minus log base b of y plus log base b of z to the power 1/4. Next step. So the first step is remove the coefficients. Next step. We're not done with the exponents yet. Put any rational exponents into radicals. So log base b of x to the 5th minus log base b of y plus log. So this is a 1/4 exponent, which means it's the 4th root of z. Now consolidate. If positive on top, if negative on bottom. So it's log base b. This one's positive, so we have x to the 5th. This one's negative, so it goes on the bottom. This one's positive, so it goes on top. You're done. As far as you can go. Example 8. Express as a single logarithm. Ln of 3x plus 1 minus ln of 3x squared minus 5x minus 2. So what do we do here? No coefficients. we have a minus sign. This is one number, this is one number. It's in parentheses. So we have ln minus ln. So what does that mean? This one goes on top. Since it's minus, this one goes on the bottom. Then what? Have we tried to factor the bottom yet? Because it's a quadratic equation. Let's see what it can equal. So the first term's a 3, so it's 3x, 3x. The signs are opposite. One's plus, one's minus. Take the first times the last term. 3 times 2 is 6. So what times what equals 6? That when we subtract them, we get, the reason we subtract is that one's a minus. We get 5. Six and 1. 6 times 1 is 6. 6 minus 1 is 5. And the bigger number gets the negative. So the 6 goes in there, and the 1 goes in there. Can we factor anything out of this one? No. 3 and 1, no. How about this one? If we can factor out a 3. They both have a 3 in common. So divide these by 3. I get x minus 2. Remove that. So that one becomes 3x plus 1, x minus 2. We can cancel the 3x minus 1s. My final answer is that. You see how we're putting everything together that we've been doing all semester now? So yeah, just because you have a quadratic, don't stop there. Factor, see if you can factor it. See what happens. Example 9 is an interesting question. It says, given that log base a of 2 is equal to 0.301 and log base a of 3 is 0.407 or 0.477. Find the following. A. Log base a of 6. Knowing this, can we find the value of this? How? You can't. 477 only equals 3. This one only equals 2. Do we know anything that we can do with 6? What is 6 made up of? It's made up of 2 times 3. which is a product. So it's log base A of 2 plus log base A of 3. Log base A of 2 is 0.301. And log base A of 3 is 0.77. Add those two together. We get 0.778. Log base A of 2/3. Very good. Log base A of 2 minus log base A of 3. 0.301 minus 0.477. It's negative 0.176. How about C? Log base A of 81. What is 81 made up of? 9 times 9. How do you get 9? Which is 3 squared times 3 squared. Because we could only use 2 and 3. So this says use the product rule. The coefficients go out in front. Two times 0.477 plus 2 times 0.477 is 9.954 plus 0.954 is 1.908. Yeah, the hardest part is figuring out how to get to it. Yes, we know that 9 times 9. We would have gone, what we were looking at was log, or 81 is made up of 3 times 3 times 3 times 3. That would have been we would have had 4 pluses here. So we would have taken 0.477 plus 0.477 plus 0.477. So it's, how can we simplify our movements? D. Log base A of 1/4. Can we do anything here? What's that? No, this is not a root, it's the function itself, it's 1/4. Remember, we have to put it in terms of log base A of 2, log base A of 3. Well, there are a couple ways we can do it. One way we can do it, 4 is made up of 2 squared. And what this gives us is log base A of 1 minus the log base A of 2 squared. Log base A of 1 is 0. And the 2 comes out in front. So we get -2 times 0.301, which is -0.602. That's one way of doing it. Another way of doing it is we could have rewritten that equation as log base A of 4 to the power -1. Because it's on the power 1, move it on top, change the exponent. So the negative exponent goes out in front. A is 2 squared. So the 2 goes out. -2 times 0.301, which is same thing. Log base A of 5. So what can we do here? Remember, all we have is log base A of 2, log base A of 3. So how can we get log base A of 5? So you're saying 2 plus 3 is 5, right? Do we know any rules that says we can do that? Those are one of the errors that students make. We can't go. That's as far as it goes. No solution. Log base A of 3 over log base A of 2. Here, just put it in there. Log base A of 3 is 0.477 over 3.01. And whatever that answer is, that answer is. And there's your answer. Or if you want to put in a calculator. All right, we have two more properties that were not discussed earlier. Log base A of X equals X. That's one of them. What this property says, if the bases are the same, then your answer is your exponent. This, actually, we did talk this one, but it put two of them together. Because if you had log base A of A to the power X, you can't have exponents, so that comes out in front. Log base A of A is 1, so this whole thing equals X, which is what that says. Example 10. Log base A of A to the power 8 equals so log base A of A to the power 8. What's the answer? 8. Very good. ln e to the power -1. Because ln is log base e. So this is log base e of e to, since the bases are the same, they cancel. So the answer is -1. Common log of 10 to the power 3k. Yeah, it's just 3k. Because this is a common log. It's already a base 10. So that's the first. And the second property that was overlooked. A to the power log base A of X is also X. If the bases are the same, they cancel. This is the base A of this exponent. This is the base of this logarithm. Since the bases are the same, the answer is just X. Four log base 4 of K. So 4 log base 4 of K is what? Okay. E to the power ln 5. Because ln is log base e. So they cancel. 10 common log 7t. Yep. And that's that section. And I went ahead and put all the, in the back of your sheet, all the summary of all the rules. And also in yours, I also put the common errors that students do. So